Hello and welcome back to another episode of Philosophy of Science, brought to you by Perspectives 4. I'm Luciano Ferzoco, and today we will be taking a deeper look into one of the key building blocks of all matter. Yes, that's exactly right. Today we will be taking a deep look into the history of atomic theory. If I were to ask you to picture an atom in your head, I'm sure that most of you would think of something like this. This is how we think of atoms today, and many of us may take that for granted. But the road to this image was kind of rocky. Believe it or not, it took thousands of years of scientific discoveries to arrive at this conclusion. The earliest known atomic theory begins with the Greek pre-Socratic philosopher named Democritus, who believed that all matter in the universe was composed of either atoms or the void. To Democritus, atoms were very small. They were solid, and they were indivisible. The void was empty space between the atoms. Democritus believed that within this huge infinite void, there were billions of atoms bouncing around. Some were big and some were small, some weighed more than others, and some were just shaped differently. When the atoms bounced around, they would interlock with one another and accumulate to create something. Well, this idea seemed like it was headed in the right direction. It was merely a philosophical view, and it lacked all empirical evidence. As such, it really wasn't that appealing. Not much progress was really made in atomic theory for quite some time, until the idea was revived 2,000 years later. Yes, 2,000 years later, in the 17th century, when a group of scientists came up with a new phenomenon that they coined Corpuscularianism. The idea was fairly similar to atomism, except for one major difference. Corpuscles could be divided. Like atoms, corpuscles were present in the void. They had varying sizes and shapes, and the arrangement of corpuscles contributed to differing noticeable characteristics of things, such as color, smell, and taste. Some famous names who endorsed the idea were John Locke, Isaac Newton, and Robert Boyle. Additionally, the theory of plenum by René Descartes also emerged at the same time. Essentially, this theory stated that all matter was extended through space. He sort of thought of the universe like a giant block of jello, completely full and no room for empty space. As a result, he didn't believe in the void. After corpuscularianism, there was another period of time in which progress was stunned, but this one only lasted about a century and a half. In the 19th century, John Dalton, an English chemist and physicist, revisited the ancient Greek atomic theory, but he sought to support it with empirical evidence. Dalton measured and recorded the weights of known compounds and elements and noticed a pattern in the weight ratios, from which he deduced atomic weights. From his observations, he established 4 principles. Number 1, all matter is composed of atoms. Number 2, all atoms of a given element have similar weights and properties. Third, compounds are combinations of 2 or more elements. And finally, a chemical reaction is a rearrangement of atoms. While Dalton is thanked for his empirical analysis and contributions towards atomic theory, a lot of work still had to be done to arrive at our current understanding. By 1897, J.J. Thompson, an English physicist, was able to boost atomic theory with his discovery of electron. His discovery was dependent on his experiments with the cathode ray tube, which allowed him to determine the mass to charge ratio of the cathode ray particles. He discovered that the masses of each particle were much smaller than any of the known atomic mass. This was really important because it led to the understanding that atoms actually were divisible, which was contrary to what Dalton believed. Electrons were negatively charged, so Thomson reasoned that there had to be another component to atoms that were positively charged, because overall atoms, they were neutrally charged. As such, the plum pudding model was arranged due to its structural similarity to the dessert. Thomson hypothesized that the atom was composed of a sea of positively charged matter in which there are negatively charged electrons. Thomson's discoveries were closely studied and revised by Ernest Rutherford, a physicist from New Zealand. Rutherford is credited with discovering the nucleus through his gold foil experiment. He sent a beam of positively charged alpha particles towards a thin sheet of gold foil. Most of the particles were able to pass through, but some deflected. When Rutherford looked at Thompson's model, he realized that this could only be true if the atom was filled with mostly empty space rather than a positively charged space, because if it were a positively charged space, most of the particles would be deflected. In order for the atom to be neutrally charged, however, there still had to be a positively charged mass within. He called this the nucleus of the atom, and he arranged it in the middle. Yet, a question still lingered. Given the positively charged nucleus, how is it that electrons manage to stay within the atom? Wouldn't they collapse towards it? Niels Bohr would show in 1913 that the atom consists of negatively charged electrons that revolve in orbits around the positively charged nucleus. He discovered that electrons travel in different orbits from one another, and that the number of electrons determine the characteristics of the element. 13 years later, Erwin Schrödinger, an Austrian physicist, set out to refine Bohr's model. Schrödinger showed that electrons actually do not move in set paths around the nucleus. Because of this observation, he suggested that it was not possible to determine the exact position of electrons. Instead, he aimed to predict the position through his electron cloud model, which used advanced mathematics to map out the predicted location of the electrons. Since then, slight modifications have been made to the model. For example, in 1932, James Chadwick discovered that the nucleus was composed of the protons that Rutherford had discovered and neutrally charged neutrons. So now we can take a look at the atom that was shown earlier, and we know a bit more about its history and composition. As we have seen, it took many, many years to finally arrive at this conclusion, and it's all thanks to several dedicated and motivated scientists. Without the help of these geniuses, we wouldn't nearly know as much today about atomic theory. That'll be all for this episode of Philosophy of Science. I hope you enjoyed it, and I want to thank you so much for tuning in. Have a great night.